idea behind the data model. So the objective of the data model is to describe the structure of the database. So what are the, you can classify it into three categories: physical data model, high level data model, and the conceptual data model. Okay. So in continuation with that, okay. So these are the topics to be discussed as part of today's lecture. So we will continue with the three schema architecture, concepts related to three schema architecture, data independence. So you can use the same three schema architecture to explain the concept related to data independence. And finally, we will conclude with the various languages supported by your database management systems. Okay. So this is the diagrammatic representation for your three schema architecture. So you are going to have three different levels: external level, conceptual level, and the internal level. So in each and every level, yes, schema is associated with each and every level. So here we are going to have the external schema. So here you are going to have the conceptual schema, and here you are going to have the internal schema. And in the lowermost layer, you will be having your database. So what is the goal of this three schema architecture? The main goal of this three schema architecture is to separate the application, or is to separate the user application from the physical database. So usually user will be interacting with the application programs or in the top layer. So the thing is, so the internal details is what? The internal details is hidden from the user. So in the internal schema, so we will consider the schemas one by one. So what is the model you are going to use in the internal schema? Okay. So in the internal level, you are going to use the internal schema. The internal schema is used to describe the physical storage structure of the database. So if you compare this with the yesterday's lecture, so what is the appropriate model you can use? So for representing the physical storage data structure, you can use the physical data model. So in the internal schema, or your internal schema is going to use the physical data model. Using this physical data model, it is going to describe the information about the data storage and the access for the given database. So that is with respect to your internal schema. So second one is the conceptual schema. So the conceptual level is associated with your conceptual schema. So the objective of the conceptual schema is to describe the structure of the database. So, your conceptual schema hides the details related to your physical storage structure. So what is the concept it is going to use for describing the structure of the database? So if you recall the yesterday's topic, so your conceptual schema make use of entities, data types, relationship, user operation, and the constraints. So what you can do is you can use the representational model to describe the conceptual schema. So for internal schema, you can use the physical data model. For the conceptual schema, you can use the representational data model. Then your external level is associated with the external schema. So the external schema is going to what? So the external schema, it is going to describe the database from the user perspective. So for a given database, you are going to have variety of users. Okay. So what is the requirement of that particular user? That information will be disclosed to that particular user, and the remaining information or the remaining details will be hidden, or the remaining details will not be exposed to that particular user. So in the external schema or in the external level also, your external schema is going to make use of what? Your external schema is going to make use of your representational data model. Okay. So in the internal schema, what is the data model you are going to use? You are going to use the physical data model. This is used to describe the structure, physical storage structure. So second one is the conceptual data model. But again, you are going to use the conceptual schema. You are going to use the representational data model. So this representational data model is used to describe the structure of the database. So what are the concepts you are going to use? Entity, attributes, entities, relationship, all those things. So for the user view, we are going to use you are going to use the same representational model for the external schema. Now, so if we are going to use these three schemas, basically these three schemas is used to provide only the descriptions or it provides a description of the data. So it is not going to give any information related to your actual data. So your actual data is stored at the physical level or in the lowermost level. So if you take the external schema, okay, so if you take the external schema, see here, you will be having what? Suppose with respect to this diagram, you are having two different users using two different external schemas. So user will be what? User will be interacting with this particular application and they will submit their requirement to this particular application. So the thing is, in each and every level, what we are doing is we are representing the data in a different using different concept. So what we need to do is, so if you want to transfer if you want to process the query, you need to transfer the request from one concept to another concept. So if you see here, so each group of users, so each and every user is going to refer only their external schema. They are going to interact with the application that is available as part of their external schema. Now, with respect to this three schema architecture, what is the responsibility of your database management system? So your database management system, your database management system must transform a request. So the user will give a request according to the specification given in the external schema. So now what is the thing is, so initially the request will be in the external schema. First thing is what you need to convert, that is your DBMS need to convert the request in the external schema to the conceptual schema, and then from the conceptual schema to your internal schema, so that it can be so that it can be processed with the corresponding database. So this is in one direction. So your database is going to give you the answer. So once again, what you have to do, you need to reformat the data according to the appropriate schema in the reverse direction. So the thing is what? So you have extracted the data from the database. So the extracted data need to be reformatted so that it will be displayed according to the external view or according to the user's requirement. Now, so we are going to use the term called as mapping. So what do you mean by mapping? So the process of transforming the request and the result between the levels is called as mapping. So now you are going to transform the request from one format to another format, so that it is going to be a somewhat time-consuming process. So if you take most of the DBMS thing, suppose if the DBMS is intended for your small database, that in that particular DBMS you don't have support for your external views. But the thing is what? The complexity cannot be fully removed. Even you don't have support for external views, still there is a need to water. Still there is a need to transfer the data between the conceptual level and the internal level, and vice versa. So the result from the internal level to the conceptual level. So this is the idea behind your three schema architecture. Okay. So you are going to have three different. You can visualize the application or you are visualize the environment as a three different layers: internal layer, external layer, and the conceptual layer. Each and every layer is associated with what? Each and every layer is associated with a schema. So in that schema, what is the model you have used? So for transforming the request, so what you need to do is you need to transform the request from one format to another format. For that, it is going to take some time. So it is going to be somewhat time consuming process. So your DBMS, who is responsible for performing this formatting operation, it is the responsibility of your database management system. So the next concept related to your three schema architecture is data independence. So you can use the same three schema architecture to explain the concept related to data independence. So how will you define data independence, or what do you mean by data independence? So the thing is, data independence is defined as the capacity to change the schema at one level of a given database system without changing the schema at the next higher level. Okay. So now based on this, you can have two types of data independence. One is called as logical data independence and another one is called as physical data independence. Clear? So the idea of data independence is it is the capacity to change the schema at one level without modifying the schema in the next higher level. So that is the idea behind the data independence. So first we will start with the logical data independence. So your logical data independence is the capacity to change the conceptual schema. So again I am using the same diagram. So now what is the requirement is you need to modify the content in this conceptual schema without modifying the without modifying the next higher level. So that is the idea behind your logical data independence. So the capacity to modify the conceptual schema without modifying the external schema and their associated application programs is called as your logical data independence. So now you may ask a question. So what is the need? What is the need to modify what? What is the need to modify the content in the conceptual schema? So here they have listed some scenario. So now the thing is, so after configuring the database, sometime there may be a need to expand the database. So you are going to add you are going to add some additional data item. Then there may be a chance to there may be a requirement to modify the constraints, or there may be a requirement to add some new constraints. You are going to reduce the database. Reduce the database means you are going to reduce the number of fields. See here, first one is expand the database means you are going to add some additional data. You are going to add some additional fields. In the case of reducing the database, you are going to remove or you are going to delete some existing data fields. Now, this point is with respect to this case. Suppose you have, initially you have 3 fields. Now you have removed 1 field. You are having only 2 fields in the existing table. So now the thing is, even if you incorporate some change in the existing database, you should not modify the you should not modify the application program that is available or that is used as part of your external schema. So with respect to this case, your external schema, the application in your external schema, what it is going to do, it will refer only to the remaining data. Okay, so initially, for example, I am saying initially you had 3 fields, now you have removed 1 field, and with respect to that scenario, your external schema will refer to what? Will refer to the current 2 fields that is available in the database. So what is the requirement is, so what you have to do is, so for achieving this logical data independence, you need to incorporate modification only in this external and conceptual mapping. Only this mapping information need to be modified. So what is the idea behind logical independence? Even if you modify the even if you modify the structure of the database, your program without modifying the application program or the same application. You have to use the same application program to extract or to interact with the modified database. So that is the idea behind your logical data independence. So next is about physical data independence. Now physical data independence is so here. So I want to modify the concept in the internal schema without modifying the conceptual schema. Okay. So basically, what is data independence? It is the capability to modify the schema in one level without modifying the schema in the next higher level or without affecting the next higher level schema. So logical means you are modifying the conceptual schema without modifying the external schema. In the case of physical data independence, it is the capacity to change what? It is the capacity to change the internal schema without changing the conceptual schema. Now the question is, what is the need to change the internal schema, or when will you change the internal schema? So the thing is, see, suppose here what we have discussed, so this internal schema is related to what? Physical storage. So now initially you have stored the data using one format. Now what is the requirement is, I need to, in order to increase the speed, what I need is, I want to reorganize the data. Or suppose one is I want to reorganize the data, or I want to add some additional access structure. So initially I don't have index, now I want to add an index file. So initially I have stored the data as a what? Initially I have stored the data in the form of a clustering. I want to store it in the non-clustered format. So the thing is, if you are going to reorganize the data, it is not going to affect the water. It is not going to affect the next higher level. Okay. So you should be in a position to access. You should be in a position to access the data without incorporating any change in your conceptual schema. Okay. So you can use the water, you can access the data without modifying the content in the conceptual schema. Okay. So the idea is, so what is the need for this? So the idea is, we are reorganizing the water. We are reorganizing the files. In the storage level, in order to increase the performance, you are reorganizing the storage structure. Even with the new storage structure, your system should be able to retrieve the data from the database without any modification. Or in other words, what I can say is, see, practically, if you visualize this, okay, see, if you take the conceptual schema, for example, if you take the conceptual schema, what is the concept you have used? You have used entity and attributes. So you can recall the concept what we have discussed in the last class. I think yesterday in the last class, I showed you an ER diagram for a car insurance database. Now so from this point, what you can infer is, if you are going to modify the storage structure, there is no need to modify the ER diagram. So there is no mapping between water. So the thing is, your ER diagram is not related to your internal storage structure. So if it is stored in the form of a dense index, you have to use this notation. Sparse index, you have to use this notation. So the notation used in the ER diagram is independent of water, is independent of your internal storage, or there is no dependency between your physical data model and your conceptual data model. So that is the idea behind your data independence. Clear? So what is the idea behind your logical data independence? You can modify the conceptual schema without changing the external schema. That is logical data independence. Physical data independence, you can modify the internal schema without changing the conceptual schema. So simply what I can say is, If I modify the program, there is no need to modify the storage structure. If I modify the storage structure, there is no need to modify the program. So if you can achieve this, then you can say that you have physical data independence as well as logical data. So next idea is about various DBMS languages. So if you are having any doubt with respect to physical data independence and logical data independence, you ask me, I will explain once again. Otherwise, I will continue with the next topic. So next idea is about what are the various languages supported by your database management system or provided as part of your database management system. So now, as of now, you have completed the database design and you have identified an appropriate database management system for implementing that particular database. So now, what is the first step is? The first step is you need to specify the conceptual schema and the internal schema. Okay. So what is the first step in the database creation process? First, you need to identify the structure, then you need to create the table. After that, you can store the data. So first step is what? First step is you need to, in the with respect to the database, first step is you need to finalize the structure related to the database or specifically structure related to the given table. So you need to identify the conceptual and the internal schema for the database and you need to finalize the mapping between these two schemas. So now you may ask a question, sir, what is the need for these various languages? Why can't we go with a single language? So the problem is we are not going to have a homogeneous users. So repeatedly what we are saying, you are going to have what? Your DBMS. So mainly your database provides support for multiple users. So the knowledge level vary from one user to another user. So what is the one of the major requirement of your database management system is it should provide an appropriate user interface for each and every user category. So our next objective is to explore the various languages and interfaces provided by a database management system. So first thing is you need to specify the conceptual schema and the internal schema. For that we are going to use the language called as what? We are going to use the language called as data definition language. Okay. So now, so the thing is, you are using a database management system. In that case, if there is no separation between the conceptual level and internal level, in that case, what you can do is you can use a single language called as data definition language. So this data definition language is used by your database administrator and as well as by your database designers to define both these schemas. So in some database management systems, you are not going to have a separation between the physical schema and the conceptual schema. If there is no difference, then what you can do is you can use the single language called as data definition language. So with respect to this data definition language, your DBMS is going to have a DDL compiler, data definition language compiler. So what is the purpose of this DDL compiler? The function of this DDL compiler is to process the DDL statement. So what is the need? So by processing, it is going to identify. So it identify the description related to the appropriate schema specs and it will store the related information in the DBMS catalog. see, one simple command what I can say is your create command. So for creating a table, you will be using create command. You will specify the table name, field name, data type. So what your DDL compiler will do is from the create command, it can identify the what? It can identify the table name, field name, data type, size, and it will store all the information as part of what? It will store all these information as part of your DBMS catalog. In some database management system, you are going to have a separation between the internal schema and the conceptual schema. So in that case, what you have to do is you can use the DDL, that is the previous language, data definition language. Your data definition language is used as part of the conceptual schema, and you are having another specialized language called as storage definition language. This storage definition language is used to specify the internal schema. Now the next question is, the thing is, you will be having mapping between the conceptual schema and the internal schema. So for representing that mapping, what is the language you have to use? Whether you need to specify the mapping using DDL or SDL, that is the user choice. So you can specify the mapping using any one of these two languages. It may be either your DDL or it may be your SDL. Clear? So data definition language, first language is data definition language, second language is storage definition language. So the third language is the view definition language. So the thing is to specify the user views. Okay, so in a true tree schema architecture, you are going to have three different layers. So this is with respect to your external view. Okay. So to specify the user view and their mapping between the conceptual schema and their mapping to the conceptual schema, you can use the language called as DDL. So in most of the database management system, your DDL is used to define both conceptual and the external schemas. So if you take a relational database management system, then your SQL is used in the role of DDL. Okay. So the thing is, see, these languages are for your understanding. So practically, we are not going to use VDL or SDL. Okay. So simply, we will be using the higher level language called as what your SQL for all the three schemas. So you can use the SQL for creating all the three schemas. Okay. So to define the user view as a result of predefined queries, what you can do is you can use this SQL. Or for your view definition language, in most of the relational database management system, your SQL itself is treated as a what? Your SQL itself is considered as the view definition language. Here, so first thing is with respect to structure. Okay. So what is the first task? You need to you need some programming language for creating the structure associated with the database. For that, what are the languages you can use? You can use data definition language, you can use storage definition language, we can use view definition language. In the relational database, instead of view definition language, we will be using SQL itself. SQL itself is used as a view definition language. So now, what is the next requirement? So next requirement is, now you have created the table. So now you want to store some data inside the table. After storing the data, you want to retrieve the data. Okay, so for that, what is the language you are going to use? So next language is called as data manipulation language. So now, after creating the various database schemas, so your database will be populated with the data. Now, after storing the data inside the database, what is the requirement? As a user, you need some mechanism to manipulate the data that is available inside the database. So what are the various manipulation you can do? So you want to retrieve the data, that is select them, or you want to display the you want to display the data that is available inside the database, you want to insert a new record, you want to update an existing record, you want to remove a record from a database. So these are the various manipulations you can perform with the data that is available in the database. So for that you can have some predefined operations, some built-in functions. So all these things are available as part of your data manipulation language. Or for performing all these operations, you can make use of the language called as what? You can make use of the language called as data manipulation language. So now so now if you take the current database management system, we are going to have some integrated language. So you can use that language to specify the what? To specify the conceptual schema, view definition, as well as your data manipulation. So only thing what we are going to do is we are going to keep the information related to the storage separately. So that information will be used by your database administration staff. So one example for this comprehensive integrated language is your SQL. So you can visualize this SQL as a combination of what? DDL, BDL and DML. So as part of DDL, what are the things you can do? Or what you can do is using this SQL, you can create a table, you can perform various manipulations with the data that is available inside the table. After creating the table, you can add some constraints to the table. Then whenever you are going to have some schema evaluation, you can incorporate all those schema evaluation in the existing database. So for all these operations, you can use a single programming language called as what? Single programming language called as SQL. So we are going to have a detailed discussion about the various functionalities available in SQL as part of your second unit. Okay. So now you can classify your database, you can classify your DML, that is your data manipulation language, into two types. One is called as high level or non-procedural DML. So the thing is, second one is, first thing is high level or non-procedural DML. Second one is low level or a procedural DML. So what is the difference? So the thing is, you are having a database. So for retrieving the data from the database, you are going to have a SQL query. How you are going to interact with the database? That is, whether you are going to interact with the database directly using a SQL query, or your SQL query is embedded inside the programming language. So if you can use the SQL query on its own for performing the complex database operation, then it comes under the category called as what? Non-procedural DML. So what we are going to have? We are going to have a command prompt. So directly what you can do is, from the command prompt, directly you can interact with the database. As a user, you can use an appropriate SQL command to interact with the database. So the thing is, your high level, okay, so your high level DML statements are entered interactively from a monitor. Okay, or what you can do is, okay, so it is also possible to embed in a general purpose programming language. So now suppose if you are going to embed this in a general purpose programming language, so what you need is, you need to have a pre-compiler. So actually you are, suppose if you are placing this SQL statement inside the C programming language, your C compiler is not in a position to parse this SQL statement. So in that case, what is the requirement is, you need to have a what? First, this SQL statement need to be extracted using the pre-compiler, and it need to be processed by the database management system. So next category is the low level or procedural DML. So only thing is, so in this case, if your DML is going to be, if your data manipulation language is going to be a low level one, in that case it will be placed inside a programming language. So it will be embedded in a general purpose programming language. So now in this case, what is the difference? So if you are going to have a low level procedural language, so that SQL statement is capable of retrieving only a single record or a single object at a given time. So from a table, suppose you assume that in a table you are having some 10 records. Using this low level DML, you want to retrieve all the 10 records from the table. In that case, what you have to do is, inside the programming language, you need to form an appropriate looping constraint. So you need to place this SQL statement. What you need to place this SQL statement inside the looping constraint, so that you can so you can retrieve all the records one by one. Okay. So you can, from a given set of records, you can retrieve and process the records one by one. So limitation is, so in the next slide you will have a better information thing. So the thing is, your low level DML. So another name for your low level DML is another name for your low level DML is record at a time DML. Okay. So if you are going to place a SQL statement inside a programming language, it is capable of retrieving only a single record. So you have placed the statement. See, in a table you are having 10 records. So you want to retrieve all the 10 records and you want to display. So simply what I can write is select star from, what is the table name? If the table name is going to be student, simply I can write a select the star from student. But the thing is, so the difference is the same query. Okay, so if you are going to supply the same SQL statement as a high level statement, it is capable of what? Using a single DML statement, you can extract the multiple records, or you can retrieve many records or multiple records using a single DML statement. So another name for your high level DML is set at a time or set oriented DML. So another name for your low level DML is record at a time DML. So since it is capable of retrieving only a single record, it is called as a what? It is called as a record at a time DML. Okay. So usually what we say is, if you are going to supply a query using a high level data manipulation language, it is said to be declarative. Why it is said to be declarative? So as part of the query, what we are going to supply is, you are going to supply, okay, so what is the data you need to retrieve? Okay. So for example, from the student table, I need to retrieve only the register number. From the student table, I need to retrieve only the name. So select the register number from student or select the name from student. That is my requirement. So that will be given as part of my SQL query. So the only thing is, you will specify only the requirement. You are not going to specify any additional information. Where the data is located, how you need to identify that particular field, what is the algorithm you need to use to extract all the relevant records. So all those information is not specified as part of your query. Because of that only, the query is said to be what? Whenever you are going to supply a query in using a high level DML, it is said to be what? It is said to be a declarative one. So along with your requirement, if you are going to specify how to satisfy that, then it is comes under the category called as what? Then it is an imperative one. That is the difference between declarative and the imperative. Okay. So whenever you are going to place a DML command inside the programming language, now you are having what? You can use two different terms. One is called as the post language, another one is called as the data sub language. So your SQL statement is called as the data sub language. This particular SQL statement is embedded inside a programming language, inside a Java language or inside a C. So if it is embedded inside C or Java, you are going to refer that C or Java as the host language. So your SQL is embedded inside the host programming language. Okay. If you are going to use, if you are going to use a DML or a high level DML in a standalone interactive manner, then that particular high level DML, you can also refer that high level DML as a query language. Simply we are going to refer it as a what? Simply we are going to refer it as a query language. So these are the concepts related to your DDL and DML. So various languages inside your database management system. Okay. So the initial three things are for your understanding. So you will be using only for practical purpose, you will be using only the SQL. So as a summary, so today I have started with the concept related to the three schema architecture. You are having three different levels: internal level, conceptual level, external level. What is the schema associated? What is the schema associated with each and every level? And in each and every schema, what is the concept you have used? So using the three schema architecture, you can use the three schema architecture to explain data independence. So data independence, capability to modify the schema at one level without modifying the next higher level. So you can classify it into two types. One is the logical data independence and another one is the physical data independence. So after finalizing the database design, you need some mechanism to physically create the table. So for that, what are the various languages available as part of your database management system? You can use languages like DDL, PDL, SDL and the DML. Thank you. So if you have any doubt related to today's discussion or the topics what we have discussed so far, you can ask.